All right, let's take a little journey under the hood of your computer. We're going to talk about the single most important piece of software running on it, the operating system. This is what makes your entire digital world tick.
Think about it. It's something you do dozens, maybe hundreds of times a day. You click an icon to open your browser or a game, and poof, it just works. But that simple little click, it kicks off this incredibly complex and honestly fascinating chain of events. So let's peel back those layers and see what's really going on behind the scenes.
So, to really get this, the first thing you need to know is that not all software on your computer is the same. They basically fall into two big categories, and each one has a totally different job to do. Okay, so most of us, we live our lives up here, in the world of application programs. You know, the browsers, the games, the stuff that we actually use to get things done. But running underneath it all, kind of like the foundation of a house, are the system programs. They're working 24/7 to support the whole OS environment and make everything else possible.
And this, right here, this is the big question. Your browser needs to use the network card to get online. Your game needs to talk to the graphics card. Your word processor has to save your work to the hard drive. But there's this really powerful barrier in place, kind of like a security guard, that's protecting your computer. So how does an app safely ask for the keys to the hardware?
And that question brings us to probably the most crucial concept for understanding how an OS keeps your computer from, just crashing all the time. It all comes down to these two completely separate worlds of operation.
The answer is something called a system call. You can think of it like a special official request form. It's the only language a program is allowed to use to ask the operating system's core, what we call the kernel, to do something important for it. It is the only approved way to cross that divide we were just talking about.
So, let's break this down. User mode is where all your apps live. It's a restricted, safe little sandbox. They have no direct line to the physical hardware. And that's a good thing. Imagine if a buggy game could just start writing random stuff to your hard drive. It could wreck your whole system. But then you have kernel mode. This is the VIP section. It's the privileged inner circle where the OS itself runs, and it has full, unrestricted access to everything. It's kind of like the difference between regular citizens who can't just walk in and start flipping switches at the power plant and the city officials who have the special keys needed to run everything safely.
Now, these might look like pretty simple commands, but trust me, these are the absolute building blocks for almost everything your apps do. When you save a document, your program makes a write system call. The really cool part is that these are universal requests. A software developer doesn't need to know how to control 1,000 different models of hard drives. No, they just use the standard write call, and the OS figures out how to talk to the specific hardware you have. It's what makes software work on millions of different computers.
Okay, so we know an app makes a request using one of those system calls. But what does the operating system actually do with that request? I mean, what is it really in charge of managing all day long?
Well, it turns out the OS is like this super powerful, incredibly busy manager who's juggling a million things at once. It's in charge of loading and running your programs, managing every single thing you plug in, your keyboard, your mouse, your printer. It handles every file, making sure they're created and deleted properly. And on top of all that, it's also handling security and cleaning up any errors. It's a huge job.
And this quote just nails it, doesn't it? Without all those services provided by the OS, our applications would just be, well, useless. They'd just be isolated bits of code with no way to see our mouse clicks, no way to save our work, and no way to connect to the internet. The OS is the bridge that makes everything actually work.
So we've seen how it all works when your computer is up and running. But how does this whole complicated system even get started in the first place? When you press that power button and the screen is just black. Let's take a quick look at the boot up sequence. It's this really precise chain of command, a series of handoffs. First, your computer's built-in firmware runs a quick check to make sure all the hardware is working okay. Then, its job is to find a tiny program on your hard drive called the bootloader. The bootloader's only job is to find the main operating system kernel, load it into the computer's memory, and then it says, "Okay, my job is done," and it hands over complete control to the OS.
And that very first step is handled by firmware. You've probably heard of BIOS or UEFI before. BIOS is the old school, kind of slow way of doing things. Most modern computers now use UEFI, and it's a huge reason why they start up so much faster than they used to. It's way more efficient, it supports modern, massive hard drives, and it adds really important security features like Secure Boot.
So when you think about it, from the moment you press that power button to the instant you launch an application, and with every single click, save, and keystroke you make, the operating system is right there, in the background, acting as the master conductor, making it all happen, silently and efficiently.
So I gotta ask you, after seeing all the things it does, managing files, running programs, handling security, which one of its services could you absolutely not live without? Whichever one you pick, it's a pretty good reminder of just how fundamental this silent manager is to every single thing we do with technology today.